Today, we're diving into one of the most fundamental security flaws in modern AI systems, the prompt injection attack.
Okay, imagine this. You ask an AI to summarize a document, but instead of a summary, it just spits out its own secret system instructions. What just happened? By the end of this explainer, you'll understand the single fundamental flaw that makes this possible and why it's a huge security issue for anyone building with large language models.
At its heart, a prompt injection attack is basically a form of social engineering. But the target here isn't a person, it's the AI model itself. It doesn't rely on complex code. It just uses plain language to trick the model, and it works because of one core vulnerability in their design. And here it is. This is the root of the problem. Large language models can't really tell the difference between the instructions their developers wrote, the system prompt, and the instructions a user provides. To the model, it's all just text. It sees the developer's rules and the user's question as one combined command, and it has to decide which part to follow. This ambiguity is exactly what an attacker exploits.
So let's give this a proper name. A prompt injection is a security attack where a user's input tricks an AI model into ignoring its original instructions and instead performing some other unauthorized action. The whole point is to hijack what the model is supposed to be doing.
Let's make this really clear with a simple translation app analogy. On the left, everything is working perfectly. The system prompt says translate, the user gives it text, and the AI translates. Simple. But on the right, the user adds a conflicting order. Ignore the above directions. Because the LLM can't be sure which instruction has higher priority, the attacker's new command can just override the developer's original intent, completely hijacking the output.
So, how do attackers actually do this? Well, these injections are usually carried out in one of two ways, either directly or indirectly.
A direct injection is exactly what it sounds like. The attacker types the malicious command right into the input field, just like in our translation example. Indirect injection, though, is much sneakier. An attacker hides a malicious prompt somewhere in an external document, like on a web page. Later, when an unsuspecting user asks the AI to summarize that page, the model reads the hidden command and executes it, often without the user having any idea it's happening.
Now, you've probably also heard the term jailbreaking. It gets used a lot alongside prompt injection, but they are technically two different things with two different goals. Let's clear that up.
So, here's the key difference. Prompt injection aims to change the AI's task. It targets how the model processes input, trying to make it do something completely new. Jailbreaking, on the other hand, tries to bypass the AI's safety rules. It targets what the model is allowed to generate, trying to get it to produce content it was specifically trained to avoid.
So why does all this matter so much? Well, because when these models are connected to real systems, the consequences of a successful injection can be really serious.
Once an AI is hooked up to real data and other tools, the risks just multiply. A successful attack could be used to leak private user data, trick the AI into spreading misinformation, corrupt important reports, or in the worst-case scenarios, even execute code on connected systems.
And this isn't just a theoretical problem. As Palo Alto Networks points out, even a small manipulation can have huge effects. Imagine a healthcare AI giving wrong dosage advice, or a financial bot making disastrous investment calls, all because of a cleverly worded prompt. So, to wrap it all up, prompt injection works by exploiting an LLM's inability to separate its instructions from user data. This allows an attacker to hijack its function using nothing more than plain language. And that brings us to the single most important takeaway. If you are building anything with this tech, you have to follow a classic security principle. Treat all user input as untrusted. Every single string a user provides could be an attempt to manipulate your model.